Right. Hello and welcome. This is a C2 EdXL AS Laura video. In this one we're going to be doing a few examples of Remainder Theorem and Factor Theorem. Now we're going to start by just sort of introducing this topic. So what is the factor and what is the remainder theorem? Well, it's sort of a way of finding out what x is basically. So if you divide, say, an x cubed equation by x take 2, what is the remainder? And yeah, just generally getting some sort of insights into it. Now, so just let me just decide what we're going to do first. Right, well, I think we should do remainder theorem first. Now, the first thing, it says this video of both. So, the first thing we're going to do is just going to get you, this is going to be like a basic sort of formula that we're going to use throughout this topic. So, we'll do a first one of x plus 4 divide 2x plus 13. Now this may seem straightforward at first, but we're going to look at it in a bit more detail. So 2x, 13, obviously that's, yeah. 2x plus 13 divided by 4, so basically seeing how many x plus 4's fit into it. Again, very, very basic, but so the first thing we do is we divide this number by this number. So our first step is 2x. Now this is not the way you'd write it out normally. I'm just going to give you a bit of a head start. 2x, so it's probably not a good way of writing the divide thing. Divide by x, and obviously the x's cancel out, so that gets us 2. So then we times 2 by x plus 4, so 2x plus 4, and that is 2x plus 8, and then we take whatever answer we get here away from this, so 2x take 13, take away 2x plus 8, do over that, x is cancel out, 13 take 8 is 5, so that's the remainder. So 2x plus 13 into x plus 4, and the remainder is 5. But sometimes, so that shows us, one thing that shows us, sorry, I'll get out of the way so you can actually see that. Alright, so you've got there, yeah, answer is equal to 5. Now that tells us it's not a factor because it doesn't divide by it to get 0. So if it's 0, then it's a factor. If we long division it and it becomes a 0, it's a factor, but as it's 5 we can say it is not a factor. So that's a short way, and that's the basic way to do that. Hopefully you've got that, so go over that. Right, crazy pen, I might go red this time. I'm going for the red one, okay? So, obviously that's giving you a bit of a head start to what we're going to be doing. Let's try a little bit more complex one. Now you're starting to get the hang of it. So it says divide x squared. So we're still in the remainder theorem. X squared, take x, take 7 by x take 3. Is x? Yeah, x take 3. So x take 3. Same thing again. We do x squared over x, and that gets us x, and we times that by x take 3. Put it over here, x take 3, and that gets us x squared. Now what I didn't write before, and I should have wrote it, is the quotient. Oh, damn it. Because I just wanted to get a head start, you know what I was doing. So x squared. So the first thing we've done is we've divided it by x, so we're going to put x up here. So that gives us x squared take 3x. You simply put that underneath x squared take 3x, you take them 2 away, that gets us, if you're taking away 3x, you're adding it on, so 2x, take 7, and then again we divide it again, so x take 3 into 2x take 7, leave 2x over x, gets us 2, x's cancel out, we times this whole equation by 2, 2 in brackets, x take 3 equals 2x take 6, we take that away, take away 2x, take 6, x's cancel out, and 6 take minus 7 take away 6, and it gets you to minus 1. And that's your answer there, that's your remainder. So our quotient up here is, we've divided it by, x was the first one, so done. Yeah, we divide it by x, and then divide it by x again. So it should be there. Plus x, or basically same as 2x. So x take 3 brackets x plus x. That's our quotient and the other thing. So you can find that out if you really simplify it down, but so you can't. So hopefully that's given you a little insight again. So that's a short introduction there, hopefully you've got that. Now, we're getting on to sort of the main things here. So it says the remainder theorem states that when f(x), so this is just a function of a graph, as these have all been graphs, it is divided by x take a, the remainder will be f of a. So basically what this tells us is, if we divide, say this is going to be not going to be a correct answer. Well, actually I'll use one from here. So 3x squared plus x take 5, and if we divide that by x plus 2, we could do it the long way of sort of expanding it, sort of dividing it, and doing the long division. Sorry, I don't know if that's too zoomed in actually. Yeah, it probably is, never mind. So we could do it the long way by doing a long division, but if we put it, this says if we're dividing it by x take a, which is this x plus a, so we just change it around, flip the sign, if we put function of a into the calculator, so the opposite sign of what we're dividing it by, we should get the same answer. So first of all, let's do it the way we know we do it. So 3x squared over x, 3x squared over x will get us 3x. So we times x by plus 2 by 3x, so that gets us 3x squared plus 6x. Take them away, 3x squared cancel out. If we're taking away a positive, we're just taking it away, so it becomes negative 5x, if I've done that right. Yeah, I think I have. Take 5. Now we've still got a minus here, we've still got an x, so we do the same thing again, x plus 2 into minus 5x. Take 5, divide by minus 5x over x gets us minus 5. We times the whole equation by minus 5, so we get minus 5x plus 10. What is it, plus 10? No, take 10, sorry. Is it? Yeah, minus 5 times plus 2 is 10. Yeah. Take these away. If you're taking away a negative, you're basically adding it. So we can say that's 0 and that's minus 5. Oh wait, no, sorry. I did that wrong. Something wrong there. So, yeah. So if we put f of minus 2 into this equation, so 3x squared plus x, take 5, we put minus 2 into the equation, 3 times minus 2 squared plus minus 2, take 5, 3 squared times minus 2 gets us, so 2 squares, 4 times by 3, that's 12, take 2 plus 5, sorry, take 5, take 2, take 5, and that gets us, so yeah, 2 squared is 4, times 3 is 12, take 2, take 5, so that gets us an answer of 5, which is exactly what we got here. So that's exactly the same answer, proving that just putting that, changing the sign, putting it into the equation, we get the same answer. So I'll just move out of the way so you can actually see that. So as you can see there, I'll just zoom in on the camera a little bit. So we went, we did our normal division of 3x squared plus x, take 5, divided by x plus 2. Did our long division, and then we got to, that's not 0.5, that is just simply 5. And then up here, we just put, we got plus 2 over there, so we put minus 2 into the equation. We just get 3x squared, 3 minus 2 squared, take 2, take 5, sorry, simplified that down, and we got 5, and we got 5 there, sorry. So that is, obviously that's the remainder theorem, so that's got a remainder of 5, that is a remainder there. Now as I said, if it's got a remainder of 0, it's a factor, which is, I've mentioned that before. Now that was a remainder theorem pretty much done in 12 minutes, it's quite good I think. Again, if you don't get that, just drop a comment and I will do a few more questions. I'm going to do a few questions at the end of this tutorial, just to go through it a bit more simply, and hope you understand it. Yeah, we'll do a few more questions at the end. One of them will involve simultaneous equation. Oh, actually, I'll do it now. Yeah, I'll do it now, won't I? So, this question, still a remainder question actually, even though it's got factors in it. It says, x take 3 is a factor of x squared, x cubed, sorry, plus ax squared plus 9x plus b. Also, when px, which is that, also when that is divided by x plus 2, the remainder is 30. Find the values of a and b. So when it's divided by x plus 2, the remainder is 30. So we'll do this first. It says, we'll worry about the first bit of the equation, because obviously if it's asking us to value the values of a and b, we're going to need a simultaneous equation. So we do what we did before, or actually no, to make it simpler for ourselves, I'm going to put it into the equation, you know, where what I talked about before as being you change the sign of this, put that as x into this equation. Now the reason why we're changing the sign is because we want this to be 0, so x is going to be the opposite of that, basically, that's what we're saying. So if we put this as f3, now we know it's a factor, as it's said, so this should equal 0, so f3 equals 0. So when we put x as 3 into here, we should get 0. So 3 cubed plus a times 3 squared plus 9 3 plus b should equal 0. If we carry on sort of expanding this, if you like, so 3 cubed is 27, 3 squared is 9 plus, and we times it by a, so we get 9a plus 9 times 3 is 27 again, plus b, and that gives us 0. Simplify this down further, and basically 27 plus 27 is 54, I think, yeah, should be, plus 9a plus b equals 0. Now we are going to rearrange that equation later on, but I'll explain why. And the other part of the question, it says when this equation, so I'll write it again in a different colour. You know, it says when this equation, x cubed plus ax squared plus 9x plus b, when it's divided by x plus 2, so I'll just put, so it's when it's divided by x plus 2, I'm writing the equation out, so all I'm doing x cubed plus ax squared plus 9x plus b. Notice how we're not getting rid of that, we still need that, and when we do that, that equals, the remainder is minus 30. Now that's, the remainder of that is 0, so we can simply either do it the long division way, or we can put minus 2 into this equation, and we know that equals 30, so we're going to do that. So f minus 2 equals minus 30. So basically polynomials. So minus 2 cubed plus a times minus 2 squared plus 9 minus 2 plus b equals negative 30. Simplify this down. So minus 2 cubed minus 2 times minus 2 is 4, times minus 2 is minus 8. And 2 times 2, minus 2 times minus 2 is 4, plus 4a. And 9 times minus 2 is negative 18. That should be take away 18. Plus b. See if we've got that right. So just let me show I've got this right. Plus 18. Yeah, so we know that equals minus 30. Simplify this down. If we simplify the numbers, it gets us to 4a plus b take 26 equals negative 30. So this is our first equation. So we can rearrange this original equation to get b, because we've got b here. We can substitute the value in. So b equals actually, sorry, I was going to substitute it in, but I think the way I wrote it down in my book is probably a bit easier. So we've got equation 1, equation 2. Oh, actually no, wait, sorry. make this a bit easier. So before I do that, so 9a plus b equals negative 54. So that's one equation, and that other equation is this one. If we take, is it 1 away from 2? Yeah, 2 away from 1. So if we take this equation away from this equation, minus, that gives us an answer of 5a equals negative 50, a equals negative 10, divide both sides by 5. So if we know a is negative 10, we can put it into this equation here. So 9 times 10 is 90, so minus 90 equals, minus 90, put it into equation 1, so I just put a little 1, minus 90 plus b equals negative 54, therefore b is equal to minus 36. And we put that into our other equations to make sure it balances. So just make sure you can see all that. Yeah, you can't quite see that there. Right, so we'll zoom it out a bit, and yeah, so we started with that equation, put the f equals 3 into the equation above, simplified it down, created an equation 1 there. As we said, that equals 30, that's basically the remainder. So we know f minus 2, change the sign, it equals 30. And then we minus 2 into the equation, simplified that down to get another equation, equation 2, which is that, and then we can take equation 2 away from equation 1, or the other way around, but it still gets us 5a equals minus 50, divide both sides by 5, a equals minus 10, put that into the first equation, so minus 90, so equation 1 was 9a plus b equals 54, 9 times minus 10 is 90, so that gets us, there we are, so minus 90 plus b equals minus 54, and then we can substitute that in to get b is equal to minus 36. So, right, that's the remainder theorem there. You can see what we do with that. And right, so that was the remainder theorem. Now we're going to go on to the factor theorem. Now, it is sort of like the remainder theorem, except we use something called the quotient, which I have gone over it before, but we use it to find the factors and other stuff. Now, I said before, just then, that if the... to make sure it's actually got my face in it. Yeah. So, actually you can't avoid me, I'm just brilliant. If it equals 0, if the remainder equals 0, it goes perfectly into it. So, it's got no remainder, there's nothing left over, so it's got to be a factor to be able to divide by it. So, if it equals 0, let's start off with it says here, use a remainder theorem to show that x take 2, so back to the remainder theorem, is a factor of the cubic expression x cubed plus 2x squared plus take 5x, so x cubed plus 2x squared take 5x take 6. So this is fx basically. That's basically fx, sorry. That is really bad in mine. Some maths. I'm allergic to maths, by the way, so many people are. Obviously, not bad for someone who couldn't do it at GCSE level. Of course I could. I've got AAA star, GCSE. You know, I just did A level when I was at GCSE and I thought, you know what, I might do this as well. So, just a bit about me really. So it says, x take 2 is a factor, prove it. So if we know, when a remainder is 0, it's a factor, and the remainder, we find the remainder when we divide it by changing this sign here. So it's f2 should equal 0 if it's a factor, because there should be nothing left over when we divide it. So we've got everything there, so we can simply put f2 is equal to, all I'm doing is substituting the values in, 2 cubed plus 2 squared, sorry, 2 times 2 squared, take 5 times 2, take 6, oh, one day, and substitute that in, so 8 plus 2 squared is 4, times 2 is 8, so 8 plus 8, yeah, take 10, take 6, and that comes to 0. So we've proved it's a factor. So hopefully I'll give you a minute to just copy that down, and then I'll get rid of it, because I mean that's only proof, it's not actually answered any question yet. Right, get rid of it. Sorry, the board's a bit messy, never mind. Right, so, oh wait, actually, sorry, I should have left that equation on. So we know x take 2 is a factor of x cubed plus 2x squared. This is the same equation, I just rubbed it out. Take 5x, take 6. So that is a factor of that. But we've just proved that before. As I said, it's the same equation. All I did was rub it out because I'm a bit of an idiot. Now it says perform algebraic division to simplify that equation into the form. So we want it in fx equals x take a plus x squared plus ax plus b. That's just, it's not saying find a and b, it's just saying put it into that simplify. So we've got this factor here. We know that is a factor. So straight away, we don't need to work that out. What we need is to work this out here. Now, the best way to do this is, it's told us to use algebraic division. So we know, if this was on the exam paper, what topic to use. So, if we know that's a factor, it is 0. So if we divide x cubed plus 2x squared, take 5x, take 6, by x take 2, we know it's going to give us another factor. If we divide it by a factor, it's going to give us 0, but if with a quotient at the top, it will be another factor, be a quadratic of that factor. So let's put that into the equation. So x take 2, all I'm going to do is simply the long division of what I proved to you before when I put that. I just put this line out there. Give me a bit more space. All I'm doing is long division of how I proved it to be a factor. So you can use, now if you've done this right, the long division, it should come to exactly the same answers when you put f, change the sign of that into the equation. And we know it's 2. So x cubed over x, gets us x squared. So we put x squared up here, times x squared by this. So x squared times x is x cubed. Take 2 times x squared times negative 2, take 2x squared, and that's all we can do. And then we take them two equations away, x cubed and x squared. Sorry, x cubed cancel out, but if you take away negative, you're basically adding it. So it's plus 4x squared, take 5x, take 6. As we've not done anything with these equations here. Yeah, that's right. So that's our main bit. Now we want to, this isn't what we want, this isn't this isn't the factor. It may look, now when I first did this I thought, well 4x squared, take 6, take 5x, take 6. That's this equation. I mean, it's in the form, isn't it? I mean, it looks like a quadratic equation. So, I don't know if you can see that, but I'll just zoom in on it. So I've already probably wasted quite a lot of your time. So you see there, it says 4x squared, take 5x, take 6. And up here, it's saying put it into that form. Now you may go, well that is exactly the same as that there. But you've got to remember, we're halfway through doing an equation here. We're doing a division. You can't just pluck out a number because it looked like the same thing. What we want is the quotient bit at the top. See, we've already started to create half of it there. So if we already create half of it, what we do exactly the same thing again. So we do, it's like we're starting the equation again. So x take 2, divide by 4x squared, take 5x, take 6, and we divide 4x squared over x, so put it out here. So that's first part of the quotient, 4x squared over x, that gets us 4x, so that's the next part of the quotient, you put it in, 4x, and then we times this equation by 4x, so 4x squared, 4x times minus 2 is take 8x, and we take them two equations away. 4x is cancelled out. If we're taking away a negative, it becomes positive. So it's overall 3x takes 6. However, that's still that's still not the root. This is trying to find out the remainder, and we're trying to find out the quotient. So we do the same thing again. Still not finished until you get either a number or 0. I guess 0 is a number, but never mind. 3x takes 6. Yeah, so what we do is we do 3x over x, and that gets us 3. So that's the next part of the remainder, the quotient even. So, I mean, we could carry on simplifying this down, so 3 times x take 2, it would be 3x take 6. And if we take these two equations away at the bottom, we get 0. So I'll just move that out of the way. So we'll zoom in again if you didn't see that. So what we've done there is we've simplified it down each time, done a long division. 3x takes 6, take 3x takes 6 is 0. And our quotient is made up from, so the first thing, the quotient at the top, the x squared comes from the x cubed over the x, and that gets us that there. And then basically the quotient, and each part of the quotient is what we divided by. So we always divide by the highest power x, not necessarily the first term, but the highest power x over the x's on the outside, and that gets us the next part of our quotient. And you do this for each stage. If we had more stages, we'd add more parts to it, but that gives us our quotient. Now we know the quotient is a factor of the a quadratic sort of the factor. So now we've got them two equations. It's asking us to put it in the form of that at the top. All we need to do is write these two values over here. We know x take a is one of the factors, but it's x take 2. And we've got this x squared plus 4x plus 3. Now we could simplify this if we wanted to, but that is your end answer. Now I hope that's helped you with it. So let's see how we can sort of take this a bit further. Now I'm going to rub that off in a minute, so hopefully you've sort of seen where we've done there. So let's get rid of this. Sorry. Right, so we know when we factorised it, it came to x take 2. That was just the equation that was over here somewhere, and it came to x squared plus 4x plus 3. Simplify that down, because all we're doing here is find the x-intercepts. X take 2, x plus 3, and obviously it's positive, so we could just do x plus 1. So the x-intercepts of this cubic graph, and we know it's cubic because it's at the top there, and obviously that gets us, the x-intercepts. So the x-intercepts are -2, 2, -3 and -1. And obviously we wanted to work out the x-intercept, you times -2 by 3 by -1, so y-intercept would be -6. And x times x times x gives us a positive x cubed, so it's a positive x cubed. Now as I said, the y-intercept is -6, so the equation, when we put it on a graph, now this is very basic, but it should look something like that. So let's draw our thing, our graph. So we've got the y-axis here, we've got the x-axis. Now we know we just put the points in, so this theoretically could be -6, this could be 2, this could be -1, and this could be -3. And because it's a positive, it starts from the bottom, let's do -1, and it will look something like that. Obviously these points will be a bit more sort of up to there. Now it says in the next part, going back to C1, find the equation where fx is larger than 0. Fx is just basically this, so it goes to fx. So it's basically asking where is the graph above 0. So we look at this little part here, and I'll get a different colour, crazy blue again. This bit here, and this just goes on and on and on forever, because the graph will never be coming back down, as they're the only intercepts. We've found out, we've proven it. So it's where x is larger than 0, so it's going to be between 3 and -1. So x is, we could write simply in individual equations, or one sort of mix, which is what we're going to do. So x is larger than 3, so -3, so x is larger than -3 or equal to it, but it's smaller than -1 or equal to it, and now it's just bigger than x. X is just simply bigger than 2. So there are your two simultaneous sort of inequalities there of the graph. That is the Factor Theorem and how it applies to graphs, and we'll see you in the next video. That's been a very long one, but hopefully you managed it, and we'll see you later.